3D figures is an important concept in geometry, and so understanding different formulas, such as ones for surface areas and volumes of different 3D figures, is essential to enhance your understanding of geometry. So the first 3D figure that I really want to go over is a cube. And so with a cube, you know that it has six faces, right? So it will look something like that. Again, just a visual representation here. And if this is S, and this is S. And really your length, your width, and your height are all equal, right? So when we see what the volume of a cube is, it's S times S times S. That's S cubed. And the surface area, right? Well, the surface area is really the sum of the areas of all six faces. And so if you think about one area of one of the faces, right, that's just S squared, right? Because that's just the area of one square, and you have six faces in a cube. Therefore, your surface area is six times or 6s squared. So these are the two formulas for volume being S cubed and your surface area being 6s squared for a cube. Now, if you don't have a cube necessarily, you may have a rectangular prism. So really, for a rectangular prism, say you have a rectangular prism, it looks something like that. However, your sides are not they will not be congruent. So you will have something like you will specifically label it as L for length, and then you have W for width, and then you have H for height. And so now when you're talking about the volume, right, the volume is equal to LWH, right? Because that's the volume of the cube. And then the surface area, obviously you have LW. Now your LW is going to be the area of the base. Now you have the same up here. So you actually have 2 LW. Similarly, you have WH. You have a WH on of the face that's opposing this face. So you have plus 2 WH. And the one you're missing now is LH. So LH means this front face here, right? This face over here. There's one in the back, so you have plus 2 LH. And really, if you think about it, you are looking at length, width, and height. And really, the easiest way to remember this is you have length and you have a width, and you're multiplying that by 2, and you're really doing it for all different combinations. You have LW, WH, and LH, and then you add those add those values up to determine the surface area of that rectangular prism. So a cube is really a rectangular prism. Well, but it has side lengths that are all equal. With the rectangular prism, length, width, and height, they are all different in measure. So that's the difference between the two. And now we can look at cylinders really briefly here. So with cylinders, again, it's just something like that, right? Something like that that you can see. So that's your cylinder, right? And when you're finding the volume of a cylinder, your volume is pi r square h, and your surface area is 2 pi r squared plus 2 pi r h. You don't have to be too confused with these formulas. You can really, by looking at them, you know what they are. And you'll be surprised, it's pretty easy because this one's a cylinder, right? And with a cylinder, you know that the bases, right? So the bases for a cylinder, right? Their shape is a circle. So this is a circle, this is a circle. And we know already that the area of a circle is pi r squared, right? So if we know that the area of the circles, if the area of the circle is pi r squared and there are two circles, well, that's 2 pi r squared. So that's obviously the area of this and this combined. Now we have the area of this, right? When you think about this, what happens is, really looking at this, we have to understand that the circumference of a circle is 2 pi r. That's the perimeter of the circle, right? That's the measure of the circle, and we're multiplying that by the height to get the entire area of this lateral surface area, right? Again, when I talk about the lateral surface area, that's the area of the cylinder excluding the areas of the bases. So excluding the areas of these two circles, the lateral surface area is only 2 pi r h. So that's where you get the 2 pi r h from. Again, 2 pi r being the circumference, and you're multiplying that by the height. The volume is really just pi r squared times by the height, That's the volume, that's the amount of space that the cylinder is taking up or occupying. So that's the cylinder. And now we have, we can look at a spherical shape, or just a sphere here. So again, more like something you may see, again, I don't want to draw a circle, but something, I guess, if this makes it more clear, you have a radius here, right? More like a, so it's obviously spherical, right? It's a sphere. And the volume for this, right? The volume for this is 4/3 pi r cubed, right? And the surface area is 4 pi r squared. And there's no real technique for for memorizing these two formulas. I think with practice, it just comes. So really, you are given a radius. You may be given the diameter. If you're given the diameter, divide that by 2 to determine the radius. Once you have the radius, you're really plugging that value into these two formulas. So volume is equal to 4/3 pi r cubed, surface area is equal to 4 pi r squared, to determine the volume and the surface area respectively. You may be given a question, right, an application or something like that, where you have an ice cream, right, you have something that looks more like a cone, right, so you have something like that, to that extent, right? And they may ask you, what's the surface area, what's the volume of the ice cream cone, or something like that. And so you have to understand that this figure here could possibly be it's a cone, right? It's a cone. But then at the same time, you may wonder whether this blob of ice cream here, when you're finding its volume, could that be a sphere? And if you think that it's given as if the scoop of ice cream is in a spherical shape, then obviously when you're determining the volume of the cream here, you will be using the formula of volume is equal to 4/3 pi r cubed here. And later applications and problems, I will be going over certain problems in the later lesson. So you may be given, because here obviously when you're looking at a sphere, you don't have a defined height. You only have a radius that you're really looking at. So if they say, for instance, the volume of a cylinder is 3 times the volume of a particular sphere, and the radius of the cylinder is 2 times the radius of the a sphere, or something on those lines, then obviously you will be setting up an algebraic equation. And if, again, you need to have the strong algebra skills to solve those problems. So you'll put something like 4/3 pi r cubed, you'll have pi r squared h, and if you say that the radius of one shape is r, then the radius of the other shape may be 2r, depending on what type of problem you get. But for now in this lesson, it's just the formula. So volume is equal to 4/3 pi r cubed, surface area is 4 pi r squared. So that's a sphere now. Now comes the cone. And really, again, when you're talking about the ice cream question, it's a really common question that you may see dealing with a cone, right? An application of a cone problem. So when you have a cone, right, the volume, and you know what a cone looks like something like that. So when we have a cone and we want to find the volume of the cone, the formula is 1/3 pi r squared h. And this is quite interesting because we know that the volume of the cylinder is pi r squared h, which really indicates that if you have the same height, same radius, and for a given cone and for a given cylinder, the volume of the cone will be 1/3 of the volume of the cylinder if they have the same heights and they have the same radii. So this is quite interesting. It's just 1/3 of this volume, pi r squared h, which is the volume of a cylinder. So that's the volume. Now to find the surface area, the formula that is used is pi r squared plus pi r L. And so pi r squared, again, is this area, right? The base of the cone is the area here, the pi r squared. And when you're determining I guess you could say the lateral surface area of the cone, right? This would be the lateral surface area, excluding the area of the base. You're doing pi r L. And to determine L is really your hypotenuse. So you're drawing a height. This is your height. And this is your radius. So this is your radius, this is your height, this is your L. your L here in this case is obviously, so if you are given your height and your radius, you will do h squared plus r squared and the square root of this to determine L. And clearly this is utilizing the Pythagorean theorem, right? So doing the radical or the square root of h squared plus r squared gives you your L, and that this is your L. So it's really your lateral height, I guess you could say, or more like your slanted height. It's also denoted by pi rs. So once you get your L here using the Pythagorean theorem, you multiply that by pi and your r, again r being your radius here, so and then add that to pi r squared to determine your surface area. So those are the two formulas for a cone. And so in the later lesson I will be going over specific problems that deal with these 3D figures. So thanks for watching.